So again, major differences if you're buying a house on this type of material. The other type of material is glacial fluvial. So we had till, that's material deposited within the ice. When the ice was reaching its maximum extent, there was so much water held in the ice that sea level was depressed by 300 feet. So this was the shoreline probably about 24,000 years ago. Here's the ice. The shoreline was all the way out here. So all of this was land at one time. So there's so much water held in that ice that as it started to recede back up, this is actually some of the plumbing at the terminus of the glacier. This is all glacial ice up on here. I don't know if you see that little guy right there. That's a person. So that shows you the grandeur of what things were like back in that time. That's basically the meltwater streams coming out of that, depositing this outwash material. So huge amounts of water held within the ice, and all of that's getting let go at once. So you had large areas of braided sand and gravel being deposited in this glacial fluvial areas, mostly within the valleys of Rhode Island here. And this is what the soils look like. You'll see stratified materials. Usually it's all rock, rounded rock fragments when you dig in through here. No restrictive layers, very easy to dig. Typically these are the areas that are the easiest areas to develop. They tend to not have any high water tables within them. They're also kind of the first areas to be developed because they're so easy to develop, and they tend to be our best farmland soils also. So there's a lot of demand on finding these areas of sand and gravel in here. And again, just looking at the hydrology in these areas, high permeability, they tend to be associated with aquifer recharge areas. So all the rain that falls in basically goes into the aquifer, versus the glacial till, it hits that hard pan and then it kind of runs off, and you get a lot of runoff in those areas there. There's other parent materials, this stuff called lacustrine, that's material deposited in glacial lakes that are now drained. Volcanic ash, we got organic soils. Loess and aeolian, we'll be talking a bit about that in the next slide. Colluvium is material deposited by gravity. So if people saw that big slide up in Azo, Oregon, all of those materials there were colluvial soils, basically deposited by gravity. Alluvium, my bet is if you go to Missouri, they probably have a lot of alluvium. I don't know if you remember it any when you guys were there, but most of the country, when you start dealing with the Mississippi drainage basin, a lot of the soils are alluvial soils. They're in these floodplains here. Residuum is soils formed in place, basically the bedrock just kind of decaying and breaking down. And then we also have a lot of what we call HTM, human transported material. Huge areas of coastal areas, Providence, Boston, all the big metro areas. A lot of the soils there are old tidal marshes that were just basically filled in. So a big chunk of the South Bay of Boston is a tidal marsh. You dig down 20 feet now, you'll hit old tidal marshes in there. So that's all human transported material. Anytime a backhoe takes soil and then dumps it somewhere, you're starting basically with a brand new soil there. So post-glacial, so if you think about the ice was down here, I showed the slide about 18,000 years ago, it was out of Rhode Island. So you look to your north, you see this big huge ice sheet, you got barren, dry land that's exposed, and the climate that occurs basically is the area without ice warms up a lot quicker. You got the cold environment with the ice, and you get these winds that are generated. They're called katabatic winds coming off a glacier. So we had a period probably about 5,000-10,000 years of just dry, windy, very windy days. I showed you that whole area of George's Bank that was basically a dry lake bed. So a lot of silt and clays were kind of picked up and deposited, and that's called aeolian deposition there. So a lot of our glacial soils are actually capped by a nice deposit of silt loam, sandy loam material. So again, this is your stratified sand and gravel, and all of this is what we call loess. It's mostly silt-sized material that overlies the glacial. So this soil has two different parent materials. It's loess over outwash, and that occurs a lot in Rhode Island here. So this just shows you kind of what the area kind of looked like. Here's your ice up in through here. You got a glacial lake. Here's your drumlins and a ground moraine. This is an esker, that hole in the ice I showed with the guy up there. That's coming out and feeding into this braided meltwater stream. So you have your fluvial areas, you got your till, your lake. So this again is kind of a photo of what this area looked like about 18,000 years ago. And then when we look at soils, we're going to talk about the physical features, how we actually describe and classify a soil. So when we look at a soil profile, we're going to be looking at the layers, the different layers that you see within the soil. And we're pretty simple soil scientists. We go A, B, or C. A few other variations on that with an O and an E sometimes. But pretty much we're going to be looking at what we call the master horizons in the soil, and then describing the profile there. So we'll do that out there. Got some slides here. Some of the other properties, the texture, the amount of sand, silt, and clay. We want you to be able to calibrate your fingers to determine if you have a real sandy soil, if you got clay material, organic, and then some of these other features, the color of the soil, the estimating where the seasonal high water table is, whether or not it's a wetland. So all of those things is, pretty much what we're going to be asking you out there. It's just showing you some color there. Texture, we talked about the amount of sand, silt, and clay in the soil. It just shows you the relative features. Sand is very large size particles, 2 millimeters down to about 0.5 millimeters. So very gritty. You can feel sand. When you get silt, it's a little bit smaller in size diameter, and the difference, again, of these is just the diameter. And then when you get down to clay, that's anything less than 2 microns. So clay is so small, you need an electron microscope to be able to see it, and has some properties that are associated with that. It's very sticky. It tends to hold a lot of what's called cations. As a general rule, most of our soils in New England here, because they're very young, have very low clay. Probably less than 15% clay in most of our soils is a good estimation. So when you're looking at one of these soil textural triangles, you might see this on a test somewhere. I mentioned this. This basically shows you the separates of materials. So your clay is here from 0 to 100. Silt-sized particles, 0 to 100, and then sand goes here. I said most of our soils have less than 15% clay. So you can draw a line right across here and eliminate all these textures that you would find. When you go to school and you study soils, you have to learn all of these. And you actually spend a whole semester just feeling the soil and estimating the amount and trying to see if it's a sandy clay or a sandy clay loam, and you actually get tested on this stuff. So again, most of our textures tend to be sand, loamy sand, sandy loam, and silt loam. So it's pretty easy that you're basically going to just determine whether or not you got mostly sand. You'll be doing that in the field. Is it mostly silty feeling material, meaning it feels like talcum powder, nice and smooth, or is it kind of a mixture, and that would be a sandy loam? So a lot of times, if you don't know, most of our soils have sandy loam textures. It tends to be our dominant, but don't always quote me on that. So the color, we're going to be showing you how to use a Munsell color book, how to document color. That gives you a scientific way to actually determine what the color is. Someone would call that at 40 centimeters a yellowish brown. Someone say it's a brownish yellow. We'll actually document the exact Munsell notation as to what that soil color is. So you're going to want to be able to use a color book, and you should have those in your classrooms to practice using them. This just shows you how we do color. It's basically hue, value, and chroma. So that one up there is telling me it's a 2.5 Y is the hue, value is 6, and chroma is 1. So you always want to note the proper Munsell notation. It's hue and then V over C, value over chroma. What's that question? We'll be doing this out in the field there. So, yeah, I should probably pass around a color book so you can see it. But again, the hue is the dominant spectral series. YR means yellow-red. The value is the amount of light. So you go from anywhere from white to black. And then the chroma is the strength of the hue. So we'll be talking about that out in the field there. Water movement in soils. Again, we'll talk about how to estimate those redox features. When you start seeing blotchy coloration, patterns of gray and rust-looking material, that's where you estimate a seasonal high water table. And that's a biochemical process that forms that, which we'll talk about probably when we get to the wetland site, and we can actually see some redox. So again, we're looking at water movement in soils. This soil here, when we start seeing these blotchy color, you can see some rust in through here. You're estimating your high water table. Even though you don't see it at the time, you can say by having these redox features, that's going to be your water table. Same thing here. I got them coming all the way up in here. This soil has a water table right up to the surface. It's actually a hydrant soil. Drainage, we're going to talk about whether soil is well drained, poorly drained. That just gives you an idea as to where the depth of the water table is on the soil. So if you're up on a convex slope, you should be on your well drained areas. Side slope, it gets a little bit wetter. And then when you get into your concave drainage areas, you get into your poorly and very poorly drained soils. Whenever you read about a soil, it'll always say a Paxton soil is a well-drained soil formed in lodgement till, something like that. And then using a soil survey, I don't have access to the internet here, but you should become familiar with using both the paper, the published soil survey book here, and also using the electronic one. Everybody should have access to internet in school. All of our soils data, we used to publish paper analog copies like this. This was the Rhode Island survey that was pretty much used from 1981 up until probably about 96 or so, when all of our soils got digitized, and now everything is on a computer and on a GIS. So now the way you get official soils data, which again, if you're a consultant or anybody that needs to know what the hydrologic group is for your detention basin that you're designing, you don't want to use this book, you want to use the latest info, because we change our soils now yearly, especially in Rhode Island. One of the jobs I do is basically updating our soils maps. So we're constantly changing the mapping. We have a lot of new technology that we didn't have back when a lot of this mapping was done in the 60s and 70s, pre-global positioning systems, pre-good elevation data, pre-really good imagery. So now we have a lot of tools. We have all kind of geophysical tools, ground penetrating radar, that we can make our soil surveys a lot more accurate and better. And that's what my job is, to basically improve our data so that it's the most state-of-the-art soils data there. So the easiest way to get soils data is right on Google Maps, and there's a website on my AnySoil. You can just type in an address and get it. Actually, I should state that again. The easiest way is right on your cell phone. If you have an app called the Soil Web app, you'll be able to just click a button and it'll tell you what the soils are any place in the country. Well, for 98% of the country. We're still mapping about 2% of the country there. So Soil Web is kind of the state-of-the-art. It was basically developed by a kid in college that did it on the weekend for his, just for fun, basically. He kind of developed it, and it's one of the coolest things I've ever seen. So we'll show you how to use that out there. And this is just using a web soil survey again. If you're not familiar with using this, let me know. I can give you a PowerPoint just on using the web soil survey. And that's it. Are there any questions? How are we doing time-wise? Any questions? What we got? Oh, 11, okay. So let's go. What we're going to do is basically head out. Jillian's going to show you how to do slope.